All right, you ready? Here we go. Mercury proves relativity.
You know what? We do not talk about Mercury enough. Like, I know it's not as cool as like Venus or Mars or even any of the gas giants either, because it's pretty small and it's so hot, everything's so arid there. But if it wasn't for Mercury, we would not understand general relativity half as well as we do. And Mercury's orbit was actually the very first proof of Einstein's theory of general relativity that we ever had.
All right, here we go, guys. They got proof. Let's see it.
So when Einstein came up with his new theory of gravity in 1916, his theory of general relativity, he did that through saying, if we can imagine gravity as curved space-time, any object that has mass will curve space-time. And the bigger the object, the more it will curve the space around it, so that objects also traveling along that space will travel along that curved path and get their trajectories changed. And he said we could think of planetary orbits just like that. And when he did that, he came up with a whole new suite of equations to describe his theory of general relativity. Now, that was all well and good, but it was just theoretical. It's one thing to actually just say,
It still is theoretical as far as I can tell. Has anybody proven space-time to exist as a physical thing?
Oh, I did that yesterday. Come on.
Oh, damn. You get that Nobel Peace Prize, did you? All right.
I'm working on it. Yeah.
All right.
mass bends space-time, but you actually also have to prove that as well. And so Einstein came up with 3 tests that you could do to confirm whether this was the case. The first one, he said, would be that stars' positions would change during a solar eclipse. And that was because we were blocking out the light of the sun. We could see the stars behind it, and we could see that the light from them has been bent around the sun on their way to Earth. Now, we had to wait about 4 years to actually get that proof from Eddington in the 1919 solar eclipse. So we couldn't use that at the time in 1916 to prove it. The second test that he came up with was this idea of gravitational redshift. So a redshift is when light...
Yes, sir?
Okay. So on the left-hand side, Dr. Rebecca Smearhurst, PhD, astrophysics, whatever, Oxford.
Yeah.
They always have to put that. They can't just have like a picture of like, I don't know, something other than, by the way, you can trust me because of this framed piece of paper.
I could print one of those up too. Yeah.
I'm probably going to do the same thing, but I'm going to put Dr. Andrew Baker, PhD, PhD, PhD. Exactly. What is that? Like, well, it's a new thing.
Ah. So you got a doctorate like 4 times. Okay. How long would it take you to get PhD, 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 PhD?
Well, a bachelor's degree, well, it's usually supposed to be 4 years. It took me 5.5 to do mine because I took time off. And then a master's degree is between 2 and 3, and then a PhD, depending on the field, is usually around 3 years. So I'm going to say another 4 years, 5 years, 6 years. Past the age where I'm currently at. So, yeah, that'll be, or maybe around the same age. I don't know.
Yeah, so she's piqued my curiosity about the Eddington experiment and what it proved during the solar eclipse. That's what I'm wondering. Does light bend around an object during eclipses for some reason? Is it the refraction from the solar eclipse? You know how it does that with the light. You know how shadows triple or quadruple during the eclipse. Does that affect light in the universe? And how is that bending around a mass? I don't know.
Well, yeah, I actually have to agree with a certain level of that because I've done it myself, testing it. And yeah, shadows can change based upon proximity. But when the proximity is going to be consistent, more or less, it shouldn't be changing by a ratio, a margin like it is with eclipses that we currently experience.
Yeah. So we would see it in the stars, not just if the sun's blocked out. So you would be able to see this so-called parallax or whatever they're talking about within the stars. Yeah. Okay. I got to look that up. Yeah, I'll look into it.
has its wavelength stretched out to longer wavelengths or lower energies or redder colors, which is why we call it a redshift. And that happens because of the expansion of the universe as well, mainly, is when we observe it. But it can happen if light is also being dragged backwards by the gravitational pull of something as it tries to travel up and out of that curve.
So gravity affects light? Huh.
Well, that's what they say that black holes do. It's the only thing, aside from refraction, which black holes apparently are like super hyper refraction or some bullshit like that.
Trust them. Yeah, absolutely.
She has a piece of paper on the wall behind her. Trust her.
I want to see this in real life. That's what I'm asking. That's just me.
Space-time. Unfortunately, in 1916, Einstein didn't have any way of proving whether that was right either. In fact, we had to wait till 1954 when a chap called Popper finally proved that it was happening around stars. And the third test that Einstein came up with was whether it could predict planetary orbits. So, having observed a planet in a specific position one night, could you predict where it was going to be in a month's time from the equations that he derived? And in particular, he wanted to try and explain the orbit of Mercury, because it had long been known that Mercury's orbit was a little bit dodgy. So Newton's equations of gravity, that had been sort of the leading theory of gravity since 1713 when he published Principia, and he took Kepler's laws of planetary motion and how the planets go around the sun and generalized it into this big theory of gravity. And so whilst those equations gave really good predictions for where the rest of the planets in the sky would be after observing them, for a month later, for Mercury, it always gave slightly the wrong answer. And no one knew why that was for a very long time, until 1859, when Leverrier published a huge long list of the position of Mercury over a number of years and found that what was actually happening was that its perihelion was precessing. Planets don't actually orbit in perfect circles. They're actually ellipses. And so at some points it's a bit further away, and some points it's closer. And the point at which it's closest is its perihelion. It comes from the Latin peri meaning close and helion meaning sun. And what Leverrier found was that that wasn't always in the exact same place in Mercury's orbit. It was actually moving with Mercury. If you were actually to plot Mercury's orbit out, what it will look like, it's kind of like a spirograph pattern. Do people remember that game? I absolutely loved that game as a kid. It used to find me just going all the time with like lots of different coloured pens. Anyway, that is what Mercury's orbit would look like. So it's
not a traditional circular orbit. It does like a spirograph. Huh.
Yeah, and that's what I've been talking about for a long time as well, because if you have a singular body and then you put a satellite up on it, and that body is not rotating or anything, whatever, stationary.
Yeah.
And you want it to stay in that position, it probably will, as long as there's no other effects on it. However, as soon as you add a secondary effect on it, whether it be rotation or a vector, or even if you had two of them at the same time, and then you need to have that satellite stay in that position with its transmitter and receiver, all of a sudden there's a problem. And I've asked other people, PhD physicists, that come into Discord,
of course.
And they don't have a fucking answer for me, because sorry, it's just I know people get irritated when I bring something up so stupidly easy, but when they can't answer it and it's just a bunch of cartoons, well, guess what? I'm going to use a cartoon.
Yeah, why not?
Yeah, exactly. Keep going, man. I'm sorry.
That's all right, man. This is getting ridiculous. I don't see how they can make predictions with this. And if the answer would be, it just appears in that coordinate system, which they need a flat coordinate system to actually map this out to begin with. But yeah, that's all they're doing. And it's not predictions because they haven't got it right yet. And they're working on it, I guess. But I thought Newton had it all, the whole solar system plotted out, but obviously not. So they
Well-
needed another answer.
The hardest part about it is that they're actually using a flat coordinate system, and
Yeah.
they're completely ignoring the Cartesian coordinate aspect of it. So that's failure number 5, I think.
No,
They're
there's
just-
been tons of more.
Yeah.
Yeah,
It's moving in like 9 different directions at one time or something like that. It's just fucking stupid.
yeah, that's why they need the 2 separate reference frames with any emotions that they predict with, and that's why they needed Einstein's math, I guess. But he wasn't really a scientist; he was more a mathematician, wasn't he? From what I understand.
I think he was a theoretical mathematician that needed help quite a bit, because he even admitted that he was not very good at math. But then all of a sudden, well, he was a thief, so why would we ever believe that he wasn't stealing ideas from other people?
Well, like any other patent office worker, yes, that would have been the one. Edison too, right? Yeah, thieves. Yeah, but I mean they profit off of it, so why not?
Like if you saw it over centuries. Now that diagram I just showed is a huge exaggeration of what this effect actually looks like. A single orbit of Mercury only takes something like 88 Earth days. And so you can't see it over a single orbit. You have to wait many, many orbits for this effect to sort of stack up for you to be able to see it.
Oh,
in fact,
I got something there.
actually measured
The pre-assumption that it's actually orbiting around the sun. That's the problem. I get it. So every 88 days it supposedly orbits the sun, but they can't see it or watch it in its orbit because it's so close to the sun. It just shows up in this coordinate system. Yeah, nuts.
God damn it! It says PhD on the fucking wall.
It does. Okay. Yeah. I wonder what professor taught her this stuff. Well, I'm pretty sure there's a few that did. Maybe she actually has a PhD. You never know. 2000 with what does it say on there? What year did she graduate? 2017. Okay. We could look that up. What's her name? Rebecca what? I can't pronounce her name. I can't even really. It's blurry as hell. Yeah. Good girl. And she doesn't look bad on the eyes neither. And she has a nice British accent.
Yeah, she's not ugly. I mean, I'd probably date her. Hold on, my eyes are pretty good. So Dr. Rebecca Smethurst.
It's a Hearst. Yeah.
Smethurst. Okay, so German.
Yeah, she sounds German, but she's got a British accent. Maybe she's related to a German. Maybe Adolf. The Austrian painter. Yeah. He was a good guy.
how much it processed each year in the sky, he found that it was something like 1.5 degrees per century.
A century, according to McGonagall.
Or if you want to use a different unit, it's 5,600 arc seconds a century. So an arc...
Oh my God. So we only see it do a full orbit in our sky every half century is what they're saying?
Yeah, rewind that just like 10. Yeah, I want to hear that again because I'm not like a math genius. I dropped out of calculus too, but I know how to figure this shit out pretty quickly. If
Okay.
she
processed each
ready? Here we
year
go.
in the sky, he found that it was something like 1.5 degrees per century.
A century, according to McGonagall.
Or if you want to use a different unit, it's 5,600 arc seconds a century. So an arc minute is when you take a degree and split it into 60, and then if you take an arc minute and split it into 60 again, you get an arc second, which is a tiny, tiny unit. But sometimes movements on the sky are that tiny, and we do need to measure things in arc seconds. Now, this wasn't...
How do they determine its size, the scale it is, and the rate it's actually traveling at? If it's that minute.
Well, I hate having to do this, but Edwin Hubble, he's the one that started a lot of this bullshit. But it wasn't just him. It was also a lot of the Greeks that started it, and also the Mayans and the Chinese. And they were on point with some of this stuff. They knew it was going to happen, but it just got out of hand.
All right. Yeah. There's a lot of pre-assumptions built into this. So they built a whole science on this, didn't they? Or so-called science, or predictions or whatnot. Yeah.
Yeah,
So
textbooks.
you literally have to be staring at the sky constantly. That's why there's these telescopes that are just pointed at these objects constantly. The slightest motion,
Yeah,
which could be much billions of light years or trillion, depending on whatever scale you put it on. You could make any kind of conclusion.
exactly. And that's where they say the red shift, blue shift of light, hence Edwin Hubble. Oh yeah, well I can look at this star with this blah blah blah. It's like, oh, the other one is like this. So it's like the same fucking distance away, such as the sun and the moon and the Saturn and Jupiter and it's like Mars. It's like happens like every like however often. Oh, they're all lined up. You can't see any other of them. The only thing you can see is Mars. But then quickly after that, you can see Jupiter and then Saturn. It's like, oh, really? But they're still the same fucking size.
Yeah.
So,
never mind. Yeah.
yeah. What I really want to see, I want to see one of her paychecks. Who the fuck is paying her, and how much is she getting paid for this? Like, because a PhD, usually when people are in PhD programs, they get paid a small amount of money for the PhD research they're doing. It's like, slightly above minimum wage, but then they have still many thousands of dollars of student loan debt unless they had scholarships or grants. So I want to see the shit. How much do they get paid?
Good question. Yeah. I think these guys on YouTube are making a lot more than they say. I'm done with this theory, dude. To be honest with you, this is all of it's built on assumption. Really, they're assuming astronomy, and Eric Dubay coined it well. Astronauts, astronomy is assuming everything they do. Without really any hard evidence to really back it up.